Chapter 4, Lesson 4, Linear Functions. You will be able to represent linear functions using function tables and graphs and determine whether a set of data is continuous or discrete. Solve the following problems. The school store sells book covers for $2 each and notebooks for $1 each. Tony has $5 to spend. The function y equals 5 minus 2x represents the number of book covers x and notebooks y she can buy. Graph the function, interpret the points graphed. So our function is y equals 5 minus 2x. Let's start with 0, 1, 2, and 3. You can buy 0 book covers, which are x. You can't buy negative book covers. That's why I'm starting at 0. And I just counted up 1, 2, 3. So plug it in. 5 minus 2 times 0, which is 5 minus 0 or 5. 5 minus 2 times 1, which is 5 minus 2 or 3. 5 minus 2 times 2, which is 5 minus 4 or 1. And 5 minus 2 times 3, which is 5 minus 6 or negative 1. Now, you can't have a negative notebook either, so this point we can't use, which only leaves us with 3 points to plot. 0, 5, 1, 3, and 2, 1. Okay, and interpret the points graphed. So Tori can't buy negative covers or notebooks. Therefore, she can only buy the following combinations. She can buy 0 covers and 5 notebooks, or 1 cover and 3 notebooks, or 2 covers and 1 notebook. And this information I'm getting right from the table. 0 and 5, 1 and 3, 2 and 1. And if you recall here, book covers are x and notebooks are y. Now, I also want to point out that you do not connect these dots. And here's why. Because you're dealing with items and quantity, book covers and notebooks, you can't buy part of a notebook. Okay? You have to buy the whole notebook or not at all. And same with book covers. Because they are whole amounts, and you can't buy anything but a whole amount, you do not connect the dots. Letter B. The farmer's market sells apples for $2 a pound and oranges for $1 per pound. Mallory has $10 to spend. The function y equals 10 minus 2x represents the number of apples x and oranges y, and really the number of pounds of apples and oranges Mallory can purchase. Graph the function and interpret the points graphed. Okay, so our function is y equals 10 minus 2x. Now, again, we can buy 0 pounds of something, so we'll count up from 0. And actually, if you look at the graph, it looks like it counts by 2s. So I'm going to count by 2s here. 2, 4, 6. It doesn't matter what numbers you choose. Okay, but so use whatever your graph, whatever makes it easier depending on your graph. So plug them in. 10 minus 2 times 0 is 10. 10 minus 2 times 2 is 6. 10 minus 2 times 4 is 2. And 10 minus 2 times 6 is negative 2. Similar to the previous problem, you can't buy a negative amount. Okay, so that one we can eliminate. And now let's plot the points that are left. 0, 10, 2, 6, and 4, 2. Now this one has to do with pounds of apples and oranges. It does not matter that you buy whole pound amounts. Because it doesn't matter, and we're not talking about quantity here, we're talking about the number of pounds, but not individual oranges and apples, we can draw a line. And actually, I'm going to change this line because we would not have arrows. There we go. You would not have arrows because you can't buy negative amounts. Okay. So now let's interpret the points graphed. Okay. So Mallory can purchase the following. She can purchase, and we're just using the points that we used, 0 pounds of apples and 10 pounds of oranges, or 2 pounds of apples and 6 pounds of oranges. Let's make this font a little smaller. And last but not least, 4 pounds of apples and 2 pounds of oranges. She can buy a lot more than that, a lot more combinations, because it's a straight line, not just whole amounts, but it just says to interpret the points graph. So we only interpret the points that we plotted. Letter C, no word problem, just a simple graphing of an equation. We actually work through it the same way. We put your equation in the middle. And pick some points. Pick at least one negative, and I like to just count up. Does not matter which x values you choose. Does not matter. Okay? As long as you can plot them somewhere on your graph. So negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. So negative 1, 1. Get a bigger point here. Negative 1, 1. We're a little off. Zero, 2. 1, 3. And 2, 4. And since this is simply a line, has no other meaning to it, we can draw a straight line with arrows through the graph. And that is it. Doesn't ask us to interpret anything, so we're good to go. A function can be considered continuous or discrete. Continuous data can take on any value, so there's no space between data values for any given domain. So this example would be a continuous example because we were able to draw a line, as well as this example is also continuous because we could draw a line. The opposite of that is discrete. Discrete data have space between possible data values. So our first example on the front was discrete because we could not draw a line. Okay? So once again, graphs of continuous data are represented by solid lines, and graphs of discrete data are represented just by dots or points. So complete the following problems. Each person that enters the store receives a coupon for $5 off his or her purchase. Write a function to represent the total value of the coupon given out. Create a function table to find the total value of coupons given out for 5, 10, 15, and 20 customers. Graph the function, determine if it's continuous or discrete, and explain. A lot of stuff going on here. Let's start by making our table. 5, 10, 15, and 20. And I'm using these specific amounts because that's what it wanted me to use in the problem. We need an equation. Now, it's $5 off each person's purchase. So $5 times each person. Okay? Customers are our X value, and I know that because I have customers down here on the X line. So plug in your values. 5 times 5 is 25. 5 times 10 is 50. 5 times 15 is 75. And 5 times 20 is 100. So we wrote a function. We created our function table. Now let's graph it. 525 is about there. 1050. 1575. And 2100. We graphed it. Now determine if it's continuous or discrete. So we need to focus on our labels here. We have value, total value of coupons, and number of customers. Can you have anything other than a whole number of customers? You can't. There can only be a whole number of people, which means that the points are not connected. So let's jot this information down because this is going to be part of our explanation. So there can only be a whole number of people, which means the points are not connected on the graph. Because of this, the function is discrete. So because we can't draw that line, it makes our function discrete. Okay, so we determined if it was continuous or discrete, and we just explained. Now we are done with the problem. Letter B. A store sells assorted nuts for $5.95 per pound. Write a function to represent the total cost of any number of pounds of nuts. Complete the function table below to find the total cost of 1, 2, 3, 4, or 5 pounds of nuts. Graph the function, determine if it's continuous or discrete, and explain. Again, a lot of information happening here. So let's write our function. Nuts are $5.95 per pound, which means y equals 5.95 times x. We wrote the function. Now let's complete the function table using 1, 2, 3, 4, or 5. And let's plug them in. 5.95 times 1 is 5.95. 95 times 2 is 1190. 5.95 times 3 is 1785. 5.95 times 4 is 2380. And 5.95 times 5 is 2975. Now, 1, 2, 3, 4, and 5 represents the pounds of nuts, so we can say pounds purchased. Okay. And our y-axis would then be our total cost. So we have 1 pound would be $5.95. Let's replot that here. Let's do a little bit thicker of a line. Okay. Maybe too thick. Okay. So 1 would be $5.95. 2 would be $11.90. 3 would be $17.85. 4 would be $23.80. And 5 would be $29.75. Okay, so we completed the table and we graphed the function. Now we need to figure out if it's continuous or discrete. We are talking about pounds purchased, not quantity purchased. So because we can have any quantity, any pounds I should say, this is a continuous function. And again, because you don't have to buy nuts in whole number increments. And we'll put in parentheses, they are sold by the pound, and you don't have to buy whole pound amounts. So we just said if it was continuous or discrete, and we explained, which means we are done with the problem.